Alright guys, we finished up with prime factorization, and really that's kind of it's a very good lead-in into finding the greatest common factor. Now the greatest common factor is really what you're going to need when you want to reduce fractions. So we're going to take a look at that and how to find it. I'm actually going to show you two different ways to find it, and you're going to go ahead and pick which way you want to do for your fractions. Okay, so we'll start off with, first of all, what is it? Okay, so when two numbers have a factor in common, we call them a common factor. It's pretty simple. So a common factor. Okay, and the largest of the common factors is called the greatest common, and I don't think I'm going to make it on these lines, so you just squeeze yours in. The greatest common factor. Okay, when you are trying to reduce an equation, you can actually reduce it by any common factor, but if you find the greatest common factor, you're going to be able to do it a lot faster than if you just find like the least one. You're going to have to continue reducing over and over again, but we'll talk more about that as we get through. Okay, so like I said, there's two main ways to find the greatest common factor, and I will show you both of them, but let's take a look here at the first one. Okay, so the method one is to just list the factors. Sometimes people don't like this way because, man, you got to sit through and you got to think of all the different things that get multiplied into that number, and sometimes if it's a bigger number, it gets to be kind of hard. Okay, so in this case, it says find the GCF, that's another way of saying greatest common factor, of 18 and 24. Okay, and so what we did is we just said first, take the bigger number, because if you can take the bigger number and find the factors of it, as you're going through, you might find the one that's the greatest common factor for the other one. So we always start with the bigger one. So it's easiest if you start with 1, so you got 1 times 24, okay, and then go to 2, so 2 times 12 is 24, and then 3 times 8 is 24, and then 4 times 6 is 24. Okay, and then we list the factors of 18. You got 1 and 18, 2 and 9, and 3 and 6. Okay, so once you've listed both of them, that was step 1 and step 2, you're going to find the factors that are common. Okay, and I like to, as we're going through, I personally like to circle the ones that are common. So we both have 1, they both have 2, they both have 3, they don't have, the other one doesn't have 4, they both have 6, they don't both have 9, they don't both have 8. So it looks like that's it. So then all you got to do, you just got to find the biggest one. So in this case, the biggest one is 6. So 6 is your greatest common factor. Okay. Now we have some try these down below here. Why don't I get you started? So let's look at 8 and 10 really fast. So I'm going to start with 10 because I said let's start with the bigger number, right? So we're going to start with 10, and we have 1 and 10. We have 2 and 5. And if you go through, you got 3 doesn't go into it, 4 doesn't. Okay, 1 and 10, 2 and 5, that's it. So then you look at 8, you got 1 and 8, and 2 and 4, and that's it. So if we go through, we circle, we have 1, and we have 2. Don't forget to circle 1, because sometimes 1 is the answer, so you got to be careful. That's the only common factor. Okay, we don't have anything else, so our greatest common factor, or our GCF, in this case, is 2. That's it. Alright, so pause this for a second, go through, do the GCF of the next two problems right there, and see what you get. Alright, hopefully you worked them all out. Now let's take a look at them really fast and see how you did. So on this one, we're going to factor out 12 and 6, and so 12s are 1 and 12, 2 and 6, and hopefully you didn't forget 3 and 4. And for 6 you have 1 and 6 and 2 and 3. Okay, so let's go ahead and circle we have our 1s, we have our 2s, we have our 3s, and a lot of times people forget this one. Okay, we have our 6. So really 6 is going to be the GCF. So the GCF equals 6. Well, it's a very sloppy F, huh? So GCF is 6 because that's the biggest one. Alright, and let's now do the last one. So you got 17 and 10. And if you break down 17, you do 1 and 17. Oh, that's it. We just have 1 and 17. For 10, we got 1 and 10, 2 and 5. Okay, and for commons, we have 1 and 17, and we have 1 and 10. And that's the only thing in common. So the GCF in this one is just 1. That's the only thing they have in common. So you would not be able to reduce a fraction that has 10 and 17 in it. Okay, so that's that one. Alright, let's flip over here and let's learn the second method. Alright, so when you look at the second method, this one is, sometimes it seems like it's a little more work, but when you go through it and you have bigger numbers, especially ones that are maybe a little harder to find all the factors of or list all the factors of, this way tends to be a lot easier for people. Okay, so the second method is to use prime factorization, which we just did, right? We just did this the other day. So if you look at it, we're going to find the GCF of 18 and 24 again. Okay, and this time we're going to use the factor tree. Remember, prime factorization is the factor tree. So we take 18, break it down into 2 and 9. We circle the 2 because it's prime. And then the 9 breaks down into 3 and 3. And then we look at the 24, and the 24 breaks down into 2 and 12. And then 12 breaks down into 3 and 4. And 4 breaks down into 2 and 2. Okay, and then once you've broken it completely down, we're going to list them all out. So 18's factors are 2 times 3 times 3. And 24's factors are 2 times 2 times 2 times 3. Now, for the greatest common factor, what you do is you circle things that they have in common. So in this case, 18 and 24 both have a 2 in common, okay? And then they both have the 3 in common, but they don't have another, the 18 doesn't have another 2, and the 24 doesn't have another 3, so we can't do anything else. So you just have 2 times 3, you multiply those together, you get 6. So there's your greatest common factor, your GCF equals 6. Okay? Alright, so let's take a look here at the example that we have. Try these. We have a couple of them here. Now the thing to remember is that you always want to find the factors that are in common. Okay? So let's look at the 8 and the 10. So we're going to take 8, we're going to take 10, we're going to break them down. I'm going to use a lighter one so you can see it a little better. Okay, so 8 breaks down into 2 times 4, and 2 is prime. 4 breaks down into 2 times 2, and those are both prime. And 10 breaks down into 2 times 5, and those are both prime. So, for 8, we have 2 times 2 times 2, and for 10, we have 2 times 5. So, if you look at what's common between them, and you circle it, they both have a 2. Now, the 8 doesn't have a 5, and the 10 doesn't have another 2, so that's it. I mean, we don't even have to multiply anything together here. So the GCF for this guy is just 2. Alright, so go ahead and pause this again, and try and do the 6 and 12, and then if you're really brave, which I think most of you are, go ahead and do 30, 45, and 75, and remember, anything that ends in a 0 or a 5 can be broken down by 5. So pause this for a second and give it a shot. Alright, now let's see how we did. So we have 6 and 12. Let's break those down. Okay, so 6 is 2 times 3, and 12 is, we could do 3 times 4, how about that? the 3 being prime, and then 4 goes into 2 and 2. So we have 6 is 2 times 3, 12 is 2 times 2 times 3, and our common, we have 2 in common, we have 3 in common, so we multiply 2 times 3, and that equals 6. So our GCF is 6 for this one. Okay, alright, now let's move this guy up, and we're going to work on 30, 45, and 75 now. This will be a big one, so I'm going to give myself a little extra room here. 30, 45, and 75. Alright, so I'm going to switch back to white. It's a little brighter. Okay, so 30, I'm going to do 5 because it ends in a 0, and 6. So 5 is prime. Break down the 6. 2 times 3. We're done. Okay, let's do 5 again because it ends in a 5. And 5 times 9 is 45. And 9 broken down is 3 times 3. And finally, 5 into 75, so we go 5. Okay, and let's think about this one for a second. If you have to, go ahead and count them out. 5, 10, 15, 20, count them all the way down. Okay, it's actually 15, so 5 times 15. And then if you break down 15, you get 3 times 5. Okay, now, it's going to be a little harder in this case. You got to find things that are common to all 3. So let me give myself a little bit of room. Alright, so for number 30, there we go. So 30 is 2 times 3 times 5. 45 is 3 times 3 times 5. And 75 is 3 times 5 times 5. Okay, so if you look here, they don't all have a 2 in common, so that doesn't work. Okay, they do all have a 3 in common. So we got 3, a 3, and a 3. So those are all common. And then they all have a 5 in common, but we have this extra 3 and we have this extra 5, so we can't use those. So our GCF is going to be 3 times 5, which is 15. Okay, so GCF is 15. Alright, if you have any questions, feel free to ask.